Hello everyone and welcome to the latest installment of the IGCSE 0580 Solution Guide series. In this video we will take a closer look at paper 4.1 from the May-June exam period of 2021. So without further ado, let's get right into it. In part A of exercise 1, it is stated that the total cost of a taxi journey is calculated as, firstly, 50 cents per kilometer plus an additional 40 cents per minute. In part 1 we are supposed to calculate the total cost of a journey of 32 kilometers that takes 30 minutes. To execute this, we simply multiply 32 by 50 cents as well as 30 by 40 cents, thereby determining the total cost for that specific journey, which is $28. Next on to the second part of exercise A, where it's stated that the total cost of a journey of 100 kilometers is $98. We are supposed to show that the time taken is 2 hours. Firstly, we will subtract the fixed cost of the journey, meaning that we know the distance for the specific journey, which is 100 kilometers, and multiplied by the price per kilometer, namely 50 cents. After simplification, there are $48 which present the cost for the time traveled. Since the journey for 1 minute costs 40 cents, we simply divide $48 by 40 cents and can conclude that this journey has taken 120 minutes, which is the equivalent of 2 hours, since 2 times 60 minutes equals 120. Next on to part B of this exercise, where it's stated that 3 taxi drivers travel a total of 8,190 kilometers in the ratio 5 by 2 by 7. We are supposed to calculate the distance of each driver travels. So in step number 1, we will determine the amount of parts that the drivers in total have traveled, which is done by simply adding up the values for the ratio, which equates 14. This will serve us as the denominator for further calculations. So to find the distance traveled by the first driver, we thereby multiply the total distance with his share of the travels divided by 14, which equals 2,925. A similar approach is taken to calculate the distances traveled for drivers 2 and 3, the only thing changing the numerator of our fraction, changing from 5 to 2 to 7. Therefore, the distance traveled by driver 1 is determined as 1,170 kilometers and that of the third driver by 4,095 kilometers respectively. Adding up all of those distances traveled should in return deliver us the total travel that the 3 taxi drivers have taken, and in doing so we can figure out ourselves whether or not our calculations were correct. In part C of exercise 1, it is stated that after midnight the cost of any taxi journey increases by 45% and one journey costs $84.10 after midnight. We are supposed to calculate the cost of the same journey before midnight. To calculate the cost before the price increase means that we divide the cost after midnight by the factor that the price has been increased with, namely 45%, according to the procedure provided. Therefore, we can determine that the cost for the same journey before midnight would be $58. Next on to exercise 2 of this exam paper, where we are provided with a diagram that shows the speed time graph for the first 180 seconds of a train journey. In exercise A, we should find the acceleration in meters per second square of the train during the first 50 seconds. This can be determined by dividing the speed achieved after 50 seconds, which is 9 meters per second, and we divide this by the time traveled, which equals 50 seconds, which equals 0.18 meters per second square. This must be true since 9 meters square divided by 50 seconds can be transformed to 9 over 50 meters per square seconds, which is exactly the unit that we are looking for in terms of the acceleration of the train. Part B states that after 180 seconds, the train decelerates at a constant rate of 1,944 kilometers per hour squared. We are supposed to show that the train decelerates for 60 seconds until it stops. So similar to exercise A, we are dividing the speed that the train travels at 60 seconds prior to its stopping, meaning that the speed at this stage is 0 meters per second. So we therefore divide 9 by 60, receiving the result 0.15 meters per square second. What we need to do now is to translate the meter per second squared into kilometers per hour squared, and we know that 1000 meters are the equivalent of 1 kilometer, and to get 2 hours from seconds we need to keep in mind that 1 hour consists of 60 minutes and each minute consists of 60 seconds. Therefore, hour squared equates to 3600 seconds squared. We have now proven that both of those expressions deliver the same result. Therefore, the assumption that the train decelerates for 60 seconds until it stops has been proven right. In part C, we're supposed to complete the speed time graph, which has been visualized adding those two lines to the diagram, since we have learned in exercise B that it takes 60 seconds from there for the train to completely stop. Therefore, 180 plus 60 equals 240, and for the train to stop, it means that its speed has to come down to 0. In the final part of this exercise, we are supposed to calculate the average speed of the train for the entire journey. To do this, we will have to add up the area for each of those three shapes, two of which are a right triangle and one of which is a rectangle. Therefore, 50 multiplied 9 divided by 2 provides us with the first area being 225. For the second area, we know its width, which is 9, and to determine the length, we will have to subtract 50 from 180, therefore providing us with the answer 1170. And finally, we have to determine the area of the second right triangle, which can be determined by multiplying 9 with the difference of 240 and 180 and dividing the entire calculation by 2, and after adding all of those areas up, we know that the entire distance of the journey was 1665 meters long. So now, in order to determine the average speed of the train, we will have to divide this value by the duration of the entire journey, which is 240 seconds long. Therefore, its average speed is 6.9375 meters per second. Next, on to exercise 3, where in part A we are provided with a diagram, and it shows a solid cone and a solid hemisphere. The cone has the radius 2.4 centimeters and the slant, the height, 6.3 centimeters. The hemisphere has radius capital R centimeters, and the total surface of the cone is equal to the total surface area of the hemisphere. We are required to calculate the value for R. Additionally, we are provided with the formula of the curved surface area A of a cone with radius R and slant height L, which is A equals pi multiplied R multiplied L. And as for the sphere, we are provided with the formula of the curved surface area again, whereby A equals 4 pi multiplied R squared. So in step number 1, we will determine the entire surface area for the cone, and in the first step we will find out the area of the curved surface, which is everything except for its base. And we can do so employing the formula provided, multiplying pi with the corresponding value for R, and this in turn with the corresponding value for the slant L. In the second step, we have to determine the base, employing the formula provided, and in the final step we simply add up the size of the curved area with the size of the base, which turns out to be 20.88 pi centimeter squared. The same approach will be taken to determine the surface area of the hemisphere. Firstly, we will determine the size of the curved area, which is 2 pi capital R squared, not 4, since we are here operating with a hemisphere, and the curved surface area A was provided for an entire sphere. The base is determined using the formula provided, and adding both of those areas up delivers us the result for the entire area, which is represented by the expression 3 pi capital R squared. In a final step, we will make use of the information that the total surface area of both solids is equal. Therefore, we can equate aforementioned surface areas with one another and rearrange this equation for R and receive the result that the radius of the hemisphere is 2.638 centimeters. Part B of the exercise provides us with a diagram that shows a solid cone with radius 7.6 centimeters and height 16 centimeters. Additionally, a cut is made parallel to the base of that same cone and the top section is removed. The remaining solid has height 12 centimeters as shown in the diagram. Our task here is to calculate the volume of the remaining solid. To do this, we will firstly calculate the volume of that part of the cone that was cut, which still remains to be a cone, just in smaller size. We can easily determine its height, which must be 4 centimeters, since the remaining solid has height 12 centimeters and the entire solid the height 16. Therefore, 16 minus 12 equals 4. Additionally, working out the ratio between the height of the smaller cone with the height of the original cone, we can determine that the ratio of those is 1/4. Therefore, the length of the radius can also be determined by multiplying 7.6 with 1/4. Plugging those values into the formula as provided lets us conclude that the volume of the cut-off small cone is 15.1 centimeters cubed. To now calculate the size of the remaining solid, we simply subtract the volume of the smaller cone with the volume of the entire cone. So we see that we first need to find that exact volume, which is again done by employing the formula provided, and we can simply plug in the value for the radius and the value for the height of the cone into our formula, providing us with the size of the volume of the original cone, which is 967.8 centimeters cubed. In the final step, we simply subtract the volume of the small cone with the volume of the entire cone, which is 952.7 centimeters cubed. Next, on to exercise 4, where in part A it is stated that the exchange rate is €1 equals $1.142, and in part A it's stated that Johan changes $500 into euros, and we are supposed to calculate the number of euros Johan receives, providing our answer correct to the nearest euro. To do this, we simply divide 500 by 1.142, receiving the result that this equates to 437.8 euros, and providing our answer correct to the nearest euro means that we have to take a look at the place value behind the decimal point, which is 8, and since 8 is 5 or larger, we will have to round the digit that's in front of the decimal point up, meaning that the answer that we are looking for is 438. In part 2, it's stated that Johan buys a computer for $329 and that the same computer costs 275 euros. We're supposed to calculate the difference in cost in dollars. So to make those two values comparable, and since we're required to find the difference of the cost in US dollars, we will have firstly to convert the value of 275 euros into that of dollars, and this is performed by multiplying this by 1.142. So now both of the prices are delivered in dollars, and in a final step, to find the difference, we simply subtract the price in euros from that of the price in dollars, which is $14.95. In part B of exercise 4, it's stated that Lucy spends 3/8 of the money she has saved this month on a book that costs $5.25. We are supposed to calculate how much money she has saved this month. Let's say X represents the sum that Lucy has saved. We know that of this she has spent $5.25 and that the ratio equates to 3/8. In order to determine how much money Lucy has saved, we know that out of the entire sum, Lucy has spent $5.25, which equals 3/8. Therefore, we will have to rearrange this equation for X, and after doing so, we should be able to conclude that the money Lucy has saved this month is $14, and we should from there find out that the money that Lucy has saved this month is a total of $14. In the final part of exercise 4, it is stated that Kamal invests $6,130 at the rate of R% per year compound interest. The value of his investment at the end of 5 years is $6,669. We are required to find out the value of R. Employing the formula necessary to determine the value of money after X amount of years using compound interest as provided allows for us to set up the following equation after plugging in all of the values stated within the exercise. In step number 1, we will attempt to isolate this expression in brackets, which is done by dividing both sides of the equation by 6,130. Thereafter, in order to eliminate the exponent, which is 5, we are taking the root to the power of 5 on both sides of the equation. And lastly, in order to isolate R, we subtract 1 from both sides of it. And finally, using our pocket calculators, we should see that the rate of R% is represented by the value 1.7%. Percents means out of 100. Next, on to exercise 5, where we are provided with a diagram that shows triangle ABC, whereby X is a point on BC, and the values for AX, XC, angle ABC, and angle AXB are provided. In part A, we are supposed to calculate the length of side AC. This can be achieved as follows. Looking at triangle AXC, we can see that the length for two sides are already provided, and also that the angle AXC can easily be calculated, knowing that the angle on a straight line is 180 degrees. Therefore, this angle can be calculated by subtracting 78 from 180, which equals 102. Now all of the information that we have tells us that we are operating with two sides that enclose an angle. So we are working with the case of SAS, and now we can determine the length of AC using the cosine formula provided. After plugging in all of the values provided accordingly, we can conclude that its length is 13.47 centimeters. In part B, we are required to calculate the length for BX. Again, we will take a look at the information that is provided now in triangle ABX. And we can see that we are provided with the size of 2 angles and 1 opposite side. So whenever we work with 2 angles and with at least 1 opposite side, we can employ the sine rule. But careful, to make this possible, since we want to determine bx, we first need to calculate the size of angle XAB. And since we already know the size for 2 of its angles, we can easily determine the size of the remaining one by again keeping in mind that the sum of the interior angles of all triangles is 180 degrees. And from there we just subtract 58 and 78 degrees, which means in turn that the size of angle XAB is 44 degrees. Plugging in those values into the sine rule provided and rearranging our equation for xb, we can tell that xb, after rearranging this equation for bx, we can conclude that its size is 8.68 centimeters. In the final part of exercise 5, we are now supposed to calculate the area of the entire triangle ABC, and we can do this by working step by step and firstly calculating the area for triangle ABX and thereafter the triangle of area AXC, and in the final step we simply add the size of both areas up, providing us with the size of the entire area of triangle ABC. The area for both of those smaller triangles can be found using the SAS rule for determining the area of a triangle. So in the first case, SAS is determined by bx, which has just been calculated, ax, which is provided, and the enclosed angle, which is also provided. As for triangle AXC, we are again working with ax and xb, since their lengths have been provided, as well as the angle AXC that we also already have determined in part A of this exercise. After adding both of those areas up, we can conclude that the size of the area of the triangle ABC is 78.18 centimeters squared. Next on to exercise 6, where in part A we are provided with a Venn diagram that should be shaded in a way that it represents the region of not P in union with set Q. Everything that is not P has been shaded in blue and Q has been shaded in red. Therefore, the representation of this set is everything that's been shaded within this Venn diagram. In part B of this exercise, we are provided with the information that there are 50 students in a group, 34 of which possess a mobile phone, 39 have a computer, and 5 of which have neither a mobile phone nor a computer. Using this information, we are supposed to complete the Venn diagram that represents aforementioned information. Firstly, we will subtract all of the students from the group that have neither a mobile phone nor a computer. Therefore, we subtract 5 from 50, providing us with 45. Since 5 of them possess neither, we can fill in this gap with 5, which means there are only 45 out of this group of 50 students left, which at least possess a mobile phone or a computer. To determine how many of those possess both, we will call the missing number x and then set up the following equation. We know that 34 out of those 45 students have a mobile phone, but we need to take away those that only possess a mobile phone without possessing a computer at the same time, which is represented by this shape. Thereafter, we have to take a look at all of those students that have a computer, but also at the same time no mobile phone, which is represented by this shape here. Therefore, 39 minus x, we know for sure that 39 possess a computer, but we need to take away the number of those that we still don't know who possess a mobile phone at the same time. Since until this stage we have just represented everything that is M but not C, or C but not M, we need in a final step to make this equation work at the unknown number who possess both of those devices, which is this one. Now we can rearrange our equation for x, meaning that 28 students possess both a mobile phone and a computer. And to get our numbers for the students who either only possess a mobile phone or a computer, we now need to subtract 28 from those 34 and 39 students respectively. Adding all of those numbers up, we should see that all of the 50 students are represented. Since 6 plus 28 equals 34, plus 11 is 45, plus 5 equals 50. In part C of this exercise, we are provided with a Venn diagram that shows the number of students in a group of 30 who have brothers, sisters or cousins. In part A, we're supposed to write down the number of students who have brothers, which is everything that has been highlighted in blue. So we simply add up the numbers 2 plus 2 plus 3 plus 1, which equals 8. As for the second part of C, we are supposed to write down the number of students who have cousins but do not have sisters. This can be represented by everything that's been highlighted in red. Students who have cousins are all of those, but we need to take away those who also have sisters, which means that we have to take away those students here, leaving providing us with 3 plus 8, a total of 11 students for which this is the case. In the third part, we are required to find the negation of the union of the students who have brothers, sisters and cousins. So the union of brothers, sisters and cousins would be represented by this entire part of the Venn diagram. But since we need to use the negation, we need to find the number of students that are not part of this group, which are just 2. In the fourth part of the exercise, we are supposed to use set notation to describe the set of students who have both cousins and sisters, but do not have brothers. So students who have both cousins and sisters, this is the intersection of cousins and sisters, but do not have brothers, so we need to intersect this with the set that does not contain brothers, which is represented by the negation of set B. In the fifth part of exercise C, it is stated that one student is picked at random from those 30, and we're supposed to find the probability that this student has cousins. Since we are picking out of 30, we know that the denominator of our fraction must be 30, and to find out the likelihood for students to have cousins, we need to count all of the students that indeed have cousins and add all of those numbers up. So 8 plus 3 is 11, plus 1 12, plus 7 19. Therefore, the probability is 19 over 30. Next on to part 6, where it said that 2 students are picked at random from the students who have cousins, and we are supposed to calculate the probability that both these students have brothers. From part 5 of this exercise, we know that there is a total of 19 cousins, and cousins who have brothers are represented by this segment of the Venn diagram. There are 4 students who have cousins and brothers, so the likelihood for the first student to be chosen at random who has a cousin but also a brother is 4 over 19. And after we have taken away the first student for which is the case, our number of students with cousins has been reduced by 1. Therefore, only 18 students with cousins are left. And since we have already picked one student who has a brother and a cousin, the number of this pool also decreases by 1. Multiplying both of those probabilities delivers us the one that we are looking for, which is 2 over 57. Having arrived at the final part of exercise C, here it is said that one student is picked at random from 30 students. Event A states that this student has sisters, and event B that this student has cousins but does not have brothers. We are supposed to explain why event A and event B are equally likely. First of all, for both events, we are picking out of the entire pool of 30 students provided. And in the first case, for a student to have sisters, we take a look at the representation of the set of sisters in the Venn diagram and add up all of the numbers. So here it's 7 plus 5, which is 12, plus 2, 14, plus 1, 15. Therefore, the likelihood for event A to occur is 15 over 30. As for B, that's stated that this student has cousins but does not have brothers. So all of our cousins are gathered within this part of the Venn diagram, and there's a total of 19 cousins, which we already know. But we should take away all of those students who have cousins but no brothers, which means there are only 8 plus 7 students left for which it's the case, which also equates to 15 over 30. Therefore, we can confidently state that event A and B are equally likely. Moving on to exercise 7, where in part A we are supposed to simplify the expression x squared minus 25 over x squared minus x minus 20. To simplify this fraction, it is our goal to factorize the numerator as well as the denominator. In terms of the expression in the denominator, we will use another formula provided, allowing for us to rewrite the fraction in the following form. And here we can see that both sides of the fraction line contain the factor x minus 5. We can therefore simplify our expression to x plus 5 over x plus 4. In part B, we are required to write a single fraction in its simplest form. This is achieved by cross-multiplying both of those fractions, meaning that we multiply their denominators with one another, and then the denominator of one fraction with the numerator of the other fraction, and vice versa. In the next step, we will simply expand those two brackets as per the method provided, and thereafter simplify the numerator, providing us with the final result, which is 2x squared plus 12x minus 5 over x multiplied x plus 1. Next on to part C of this exercise, where it's stated that a curve has equation y equals 2x cubed minus 4x squared plus 6. In the first part, we are required to find the first derivative of a aforementioned function. This can be executed by using the power rule for derivatives provided, meaning that the first derivative has the equation 6x squared minus 8x. The second part states that we are supposed to calculate the gradient of the curve y equals 2x cubed minus 4x squared plus 6 at x equals 4. Our signal word here is gradient, and the gradient can be calculated at a point x, substituting for x in the equation for the first derivative, and after plugging in 4 accordingly, we can conclude that the gradient of the curve at x equals 4 has the value 64. Having arrived at part 3, where we're supposed to find the coordinates of the two stationary points of the curve, stationary points can be calculated by equating the derivative with 0. In this step, we can see that both of those summands contain the factor 2x. We can therefore factorize 2x. And at this stage, we can now find the values for x, knowing that for a product to equal 0, at least one of the factors needs to equal 0. So in the first case, 2x equals 0 if x equals 0. And for the second instance, we can rearrange our equation for x, providing us with the result that x can also be 4/3. To find the corresponding y coordinates, we simply plug 0 into the equation of the curve and do the same thing for x equals 4/3. And from there we can simply plug in corresponding values for x and y of those coordinates respectively. Moving on to exercise 8, where in part A we are provided with a table that shows information about the mass in kilograms of each of 50 children. In part 1, we are supposed to complete the cumulative frequency table. Cumulative meaning that on the go we add up all of the values combined that were stated in the original table up to this point. So to determine this value we add 3 and 19. To reach the next value we add 21 to this. To receive 48 we add another 5. And to get to 50 we add another 2, which makes sense since the total number of children observed is 50. In the second part on the grid, we should draw a cumulative frequency diagram to show this information. Plugging this information into the grid is pretty straightforward. The mass is represented by the x-axis and the cumulative frequency by the y-axis. Therefore, the point 10,3 can be found by looking for the mass being 10 kilograms and the cumulative frequency 3. We proceed similarly for all of the remaining values and thereafter connect the dots in the shape of a reasonable curve. Please do not connect those dots in a straight manner, since this would be penalized by the corrector. In the third part of part A of exercise 8, we should now use the diagram to find an estimate of the number of children with a mass of 32 kilograms or less. So we can find 32 kilograms looking at the x-axis and draw a vertical straight line from there. And where this line intersects the curve provides us with the estimated number of children for which this is the case, which according to this diagram is 37. In part B of exercise 8, we are provided with a cumulative frequency diagram that shows information about the height in meters of each of 100 students. The height of the tallest student is 1 meters and 83, and the height of the shortest one 1 meters and 45. We are supposed to draw a box whisker plot for the height of 100 students. We are already provided with the maximum and the minimum. Therefore, the whiskers can be applied accordingly, 1 meters 83 being located here and 1 meters 45 at this point. To complete the box whisker diagram, we now need to find the value of the median as well as the values of the first and third quartile. Since the information in this diagram is shown for 100 students, the median would mean half of the number of students, which we can find here, and providing a line parallel to the x-axis will help us in determining the median height, which is 1 meters and 64. As for the quartile, the first quartile means the first 25% of the population that's observed, and 25% out of 100 is 25, and we will proceed in the same way as we have done to determine the median height, delivering us the solution that the height that represents the first quartile is 1 meters and 57. The same method applies, of course, for the height that corresponds to the third quartile, which in this case is 1 meters and 71. Next on to exercise 9, where we are provided with a diagram that shows a prism ABCDEF, whereby AB, AC, CF and the angle ABC is provided. In part A, we are supposed to calculate the total surface area of the prism. Since ABC is a right angle, so is DEF. Since the triangles ABC and DEF are parallel to one another, since we are dealing with a prism. Additionally, we can assume that AB is parallel to DE, AC parallel to DF, and CF parallel to BE. Since AB and AC are given, we need to find BC. which is done through Pythagoras' rule provided, which leads to the result that the length of BC is the square root of 231. So now we're able to calculate the area of the triangle ABC, and we will multiply it with 2 since the triangle DEF is congruent to ABC. To achieve this, we are multiplying the two legs that form the right triangle divided by 2, providing us the area for one of these triangles, and multiply this by 2 since there are two instances of the same triangle. 3 more areas are missing now, namely the areas of the rectangles ABED, ACFD and BCFE. To get the area for ABED, we multiply 13 with 24, since BE is parallel to CF. As for ACFD, we are already provided with AC, and we multiply this with 24 again. Lastly, to determine the area of BCFE, we multiply the result that we have just determined, again with 24. And in the final stage, we add up the results for all of those areas, letting us conclude that the total surface area of this prism is 1354.35 centimeters squared. Part B requires from us to calculate the volume of the prism using the formula provided, the base being ABC, and as for the height, we will use CF, whereby we receive the volume being 2371 centimeters cubed. In the final part of this exercise C, we are required to calculate the angle that AF makes with the base BCFE. I've already drawn the necessary visuals for that into the diagram. So the angle that we are looking into is this one here. So we can work with the following triangle ABF, whereby angle ABF is a right angle. To be able to calculate the size of this angle using tangent, we will have to determine the length of BF, which in this case would serve as the adjacent, and the opposite AB is already provided. This can be achieved by working with Pythagoras' formula using the triangle BCF. This works since the angle BCF is also a right angle. After execution of Pythagoras' theorem, we can conclude that the length BF is the square root of 807. As previously mentioned, this allows for us to work out with the help of tangent for right-angled triangles, and after plugging in this fraction into our pocket calculators, we can conclude that the angle that we are looking for has the size 24.59 degrees. Continuing with exercise 10, where it's stated that the table shows some values of y equals 3 plus 4x minus x squared within the interval of -1 and 5 included. What we should identify here is that we are working with a quadratic function, meaning that this function is symmetrical, which we can use to our advantage. Since we are aware of the existing symmetry, we can make use of it. So here we can see that the y value for x equals -1 and x equals 5 is the same. Therefore, the symmetry must be located right between the x value of -1 and 5. And this can be found by adding up the values of 5 and -1 and dividing it by 2. This is the same formula that we would use in order to calculate the midpoint between 2 points provided. This leads to 4/2, which is the same as 2. Since the coefficient of x squared is negative, it means that the coordinates 2, 7 represent the maximum value of this quadratic function. Additionally, we just need to do 2 more calculations, namely plugging in -0.5 for x and 0 for x, and after that we can simply copy the values over, making use again of our knowledge that quadratic functions are symmetrical. In part B of this exercise, on the grid below, we are supposed to draw the graph within the same interval mentioned above. So what we will now do is use all of those coordinates provided in the table, put in the values accordingly, and connect those in a way that this graph resembles a parabola. In part C of this exercise, we are supposed to write down an integer value for k, for which the equation 3 plus 4x minus x squared equals k has no solutions, and this is the case for any integer that is 8 or above, since the maximum y value that this quadratic function can reach is 7. And the next integer after that is 8, the following one would be 9, and so on. So every value that is 8 or larger than that provides us with a legitimate solution. Looking at part D of exercise 10, by drawing a suitable straight line on the grid, we are supposed to solve the equation -1 plus 9/2x minus x squared equals 0. This can be achieved by setting up 2 simultaneous equations. And after writing those neatly above one another, we can see that if we were to subtract the second equation from the first equation, that you would receive a solution resembling a line equation, since y minus 0 equals y and negative x squared minus negative x squared means that x squared gets eliminated. The y-intercept is determined by calculating 3 minus negative 1, which is 4, and as for the gradient of that line, we simply calculate 4 minus 9 over 2, which is negative a half. To draw this line onto the grid above, we will employ the intercept gradient method. Our intercept is to be found at the coordinates 0, 4, and from there, according to our gradient, moving 1 unit down and 2 units to the right allows for us to find a second point on the line. And now that we're provided with 2 points of the line, we can simply connect the dots and extend the line within the required interval of negative 1 and 5 included. Next on to exercise 11, where in part A we are supposed to find the size of an exterior angle of a regular polygon with 18 sides. You should keep in mind that the exterior angle of any regular polygon adds up to 360. Therefore, to find out the angle for one of those exterior angles, we simply divide 360 by 80, which provides us with a solution that the size of the exterior angle is 20 degrees. Next on to exercise B, where we are provided with a triangle ABCD, whereby BE and CD are parallel to one another as stated, but which can also be seen by each of those lines containing one feather, which symbolizes that those lines are parallel to one another. Additionally, the lengths of CD, ED and AE are provided, which means that the length of AD can simply be calculated by adding up the lengths of AE and ED. We are supposed to calculate BE, since we are working within a diagram that contains 2 rays and 2 parallel lines. We can work with the laws of radiation as provided. Therefore, we can conclude that the ratio of BE and CD is equal to the one of AE and AD. Thereafter, we will rearrange the equation for BE and plug in the values for the sides accordingly. With the assistance of our trusted pocket calculator, we can conclude that the length of BE is 4.5 centimeters. In part C of this exercise, it's stated that 2 solids are mathematically similar. The smallest solid has height 2 centimeters and volume 32 centimeters cubed, and the largest solid has volume 780 centimeters cubed. We're supposed to calculate the height of the largest solids. Since both solids are mathematically similar, we know that the height of the largest solid relates to the height of the smaller one, in the same way as the cubed root of the volume of the larger one relates to that of the smaller one. Since we are comparing heights on the left-hand side of the equation, we need to do the same thing on its right-hand side, meaning that we will have to take this cubed roots of the volumes in order to get from centimeters cubed to centimeters. Rearranging this equation for h and using our pocket calculators, we can conclude that the height of the largest solid approximates to 5.80 centimeters. Next on to part D of exercise 11, where it's stated that PQ and RS are parallel to one another, again as indicated by the feathers. Additionally, it's stated that P and S is a straight line and N is the midpoint of the line PQ. We should explain giving reasons why triangle PQN is congruent to triangle SRN. Firstly, we can state that angles P and Q and S and R are equal, since both angles are opposite. QPN and RSN are also the same, since we are working here with alternate angles. And for the same reason, NQP and NRS are identical as well. And lastly, since N is the midpoint of QR, we know that QN and NR must be of equal length. This leads us to the final exercise of this exam paper, exercise 12, where we are provided with 3 functions. And in part A, we are required to find the value for f of negative 5, which means we simply plug in negative 5 for x and conclude that the corresponding y value is 13. In part B, we need to find f of x, meaning that we will substitute 3 minus 2x for x. Providing our answer in its simplest form, after simplification lets us conclude that f of x can be expressed through 4x minus 3. In part C, we are supposed to solve the equation g of x equals f of x plus 37, so we simply substitute g of x for x squared plus 5 and f of x for 3 minus 2x. We will rearrange this equation for a quadratic equation. And in this stage, in order to be able to factorize, we will employ the method provided. Thereafter, we can rephrase this equation for x squared minus 5x plus 7x minus 35. And looking closely at the first two summands on the left-hand side, we can conclude that both of those contain the factor x. And for the latter two, we can see that both of these contain the factor 7. Now, taking a look at this equation, we can see that both of these summands contain the same factor, namely x minus 5. And after factorizing this, we can transform the left-hand side of the equation into the expression x plus 7 multiplied x minus 5. Since for a multiplication to equal 0, at least one factor needs to be 0, we can conclude that either x equals negative 7 or x equals 5. In part D, we are supposed to find the inverse of f of x. We can achieve this by rewriting f of x by substituting x for y and vice versa. And after rearranging this equation for y, we can conclude that the inverse of the function f of x can be expressed by the fraction minus x plus 3 over 2. In the final part of exercise 12, we are supposed to find h of f of x plus g of x. H of x is x cubed, therefore we must cube the expression for f of x. G of x is as stated in the exercise x squared plus 5, and now we will add up both of those expressions. To expand these brackets, we will have to rewrite those as 3 minus x squared multiplied 3 minus x. Using the whole square rule provided, we can expand this expression into 9 minus 12x plus 4x squared. In the final step, we simplify this expression for as much as possible and can conclude that h of x plus g of x in its simplest form is represented by the expression negative 8x cubed plus 37x squared minus 54x plus 32. I've been your host Marco from Planet Maths. Should you derive any value from my videos, please consider to leave a like, comment and subscribe. Thank you for watching. Cheers.